Welcome to the I Can Sleep podcast, where I read random articles from across the web to bore you to sleep with my soothing voice. I'm your host, Benjamin Boster. Today's episode is from a Wikipedia article titled Philodendron. Philodendron is a large genus of flowering plants in the family of Araceae. As of September 2015, the World Checklist of selected plant families accepted 489 species. Other sources accept different numbers. Regardless of number of species, the genus is the second largest member of the family Araceae, after genus Anthurium. Taxonomically, the genus Philodendron is still poorly known, with many undescribed species. Many are grown as ornamental and indoor plants. The name derives from the Greek words philo, love, affection, and dendron, tree. The generic name Philodendron is often used as the English name. Compared to other genera of the family Araceae, philodendrons have an extremely diverse array of growth methods. The habits of growth can be epiphytic, hemiepiphytic, or rarely terrestrial. Others can show a combination of these growth habits depending on the environment. Hemiepiphytic philodendrons can be classified into two types: primary and secondary hemiepiphytes. A primary hemiepiphytic philodendron starts life high up in the canopy where the seed initially sprouts. The plant then grows as an epiphyte. Once it has reached a sufficient size and age, it would begin producing aerial roots that grow toward the forest floor. Once they reach the forest floor, nutrients can be obtained directly from the soil. In this manner, the plant's strategy is to obtain light early in its life at the expense of nutrients. Some primary epiphytic species have a symbiotic relationship with ants. In these species, the ant's nest is grown amongst the plant's roots, which help keep the nest together. Philodendrons have extrafloral nectaries, glands that secrete nectar to attract the ants. The philodendron, in turn, obtains nutrients from the surrounding ant nest, and the aggressive nature of the ant serves to protect the plant from other insects which would eat it. Secondary hemiepiphytes start life on the ground or on part of a tree trunk very close to the ground, where the seeds sprout. These philodendrons have their roots in the ground early in their lives. They then begin climbing up a tree and eventually may become completely epiphytic, doing away with their subterranean roots. Secondary hemiepiphytes do not always start their lives close to a tree. For these philodendrons, the plant will grow with long internodes along the ground until a tree is found. They find a suitable tree by growing towards darker areas, such as the dark shadow of a tree. This trait is called scototropism. After a tree has been found, the scototropic behavior stops, and the philodendron switches to a phototropic growth habit, and the internodes shorten and thicken. Usually, however, philodendrons germinate on trees. The leaves are usually large and imposing, often lobed or deeply cut, and may be more or less pinnate. They can also be oval, spear-shaped, divided, or many other possible shape variations. The leaves are borne alternately on the stem. A quality of philodendrons is that they do not have a single type of leaf on the same plant. Instead, they have juvenile leaves and adult leaves, which can be drastically different from one another. The leaves of seedling philodendrons are usually heart-shaped early in the life of the plant. But after it has matured past the seedling stage, the leaves will acquire the typical juvenile leaves shape and size. Later in the philodendron's life, it starts producing adult leaves, a process called metamorphosis. Most philodendrons go through metamorphosis gradually. There's no immediate, distinct difference between juvenile and adult leaves. Aside from being typically much bigger than the juvenile leaves, the shape of adult leaves can be significantly different. In fact, considerable taxonomic difficulty has occurred in the past due to these differences, causing juvenile and adult plants to mistakenly be classified as different species. The trigger for the transformation to adult leaves can vary considerably. One possible trigger is the height of the plant. Secondary hemiepiphytes start off on the dark forest floor and climb their way up a tree, displaying their juvenile type leaves along the way. Once they reach a sufficient height, they begin developing adult type leaves. The smaller juvenile leaves are used for the darker forest floor, where light is in scarce supply. But once they reach a sufficient height in the canopy, the light is bright enough that the bigger adult leaves can serve a useful purpose. Another possible trigger occurs in primary hemiepiphytes. These philodendrons typically send their aerial roots downward. Once their roots have reached the ground below, the plant will begin taking up nutrients from the soil, of which it had been previously deprived. As a result, the plant will quickly morph into its adult leaves and gain in size dramatically. Another quality of philodendron leaves is they are often quite different in shape and size, even between two plants of the same species. As a result of all these different possible leaf shapes, it is often difficult to differentiate natural variations from morphogenesis. Philodendrons also produce cataphyls, which are modified leaves that surround and protect the newly forming leaves. Cataphyls are usually green, leaf-like, and rigid, while they are protecting the leaf. In some species, they can even be rather succulent. Once the leaf has been fully formed, the cataphyl usually remains attached where the stem and base of the leaf meet. In philodendrons, cataphyls typically fall into two categories: deciduous and persistent types. A deciduous cataphyl curls away from the leaf once it is formed, eventually turning brown and drying out, and finally falling off the plant, leaving a scar on the stem where it was attached. Deciduous cataphyls are typically found on vining philodendrons, whereas persistent cataphyls are typical of epiphytic philodendrons or oppressed climbers. In the latter, the cataphyls are prevented from falling off in a timely manner due to the short internodes of the plant. The cataphyls will remain attached, drying out and becoming nothing more than fibers attached to the nodes. In some philodendrons, the cataphyls build up over time and eventually form a wet mass at the nodes. This may keep emerging roots moist and provide some form of lubrication to new leaves. Philodendrons have both aerial and subterranean roots. The aerial roots occur in many shapes and sizes and originate from most of the plant's nodes, or occasionally from an internode. The size and number of aerial roots per node depends on the presence of a suitable substrate for the roots to attach themselves. Aerial roots serve two primary purposes. They allow the philodendron to attach itself to a tree or other plant, and they allow it to collect water and nutrients. As such, the roots are divided morphologically into these two categories. Aerial roots used for attaching to trees tend to be shorter, more numerous, and sometimes have a layer of root hairs attached. Those used for collecting water and nutrients tend to be thicker and longer. These feeder roots tend to attach flush with the substrate to which the philodendron is attached, and make their way directly downwards in search of soil. In general, feeder roots tend to show both positive hydrotropic and negative heliotropic behaviors. Characteristic of roots in philodendrons is the presence of a sclerotic hypodermis, which are cylindrical tubes inside the epidermis that can be 1 to 5 cells long. The cells that line the sclerotic hypodermis are elongated and tend to be hardened. Underneath the epidermis is a unique layer of cells in a pattern of long cells followed by short cells. Some philodendrons have extrafloral nectaries, nectar-producing glands found outside of the flowers. The nectar attracts ants, with which the plant enjoys a protective symbiotic relationship. Nectaries can be found in a variation of locations on the plant, including the stalks, sheaths, lower surfaces of the leaves, and spathes. The nectaries produce a sweet, sticky substance the ants like to eat, and which provides an incentive for them to build their nests amongst the roots of the given philodendron. In some cases, the amount of nectar produced can be quite extensive, resulting in the surface becoming entirely covered with it. Botanically, the fruit produced is a berry. The berries develop later in the season. Berry development time varies from species to species, from a few weeks to a year, although most philodendrons take a few months. The spathes will enlarge to hold the maturing berries. Once the fruit are mature, the spathes will begin to open again, but this time it will break off at the base and fall to the forest floor. Additionally, the berries are edible, although they contain calcium oxalate crystals and have a taste akin to bananas. Many botanical sources will indicate that berries are poisonous, probably due to the oxalate crystals. Many tropical plants contain oxalates in varying amounts. Sometimes proper preparation can render these harmless, and in many cases, eating minor amounts causes most people no distress or minor gastric irritation. However, care should be taken to verify the toxicity of any particular species before ingesting these berries, particularly regularly or in large amounts. The color of the berries can vary depending on the species, but most produce a white berry with slight tones of green. Some produce orange berries and others yellow berries, though. Still others will produce berries that start off white, but then change to another color with time. Philodendrons that produce orange berries tend to be members of the section Calostigma. Contained within the berries are the seeds, which are extremely small compared to other members of the family Araceae. The berries often give off odors to attract animals to eat and disperse them. For example, Philodendron meliodorum berries are known to emit an odor similar to that of garlic. The animals that distribute the seeds depends on the species, but some possible dispersers include bats and monkeys. Insects also may be responsible for dispersing seeds, as beetles and wasps have been seen feeding on philodendron berries. Eurytimid wasps also seek out philodendrons and are known to lay their eggs in the ovaries of many philodendron species, resulting in galled inflorescences. Philodendrons exhibit extremely few physical reproductive barriers to prevent hybridization, but very few natural hybrids are found in nature. This may be because philodendrons have many geographic and time barriers to prevent any such cross-pollination. For example, it is rare for more than one philodendron species to be flowering at the same time or to be pollinated by the same species of beetles. The beetles have also been observed to be selective to the height of the plant they pollinate, which would serve as an additional preventative measure to make hybrids less likely. Because of these outside barriers, philodendrons may not have had to evolve physical mechanisms to prevent cross-pollination. Hybrids in nature are only rarely reported. When found, these hybrids can often show remarkable genetic relationships. Crosses between two philodendrons in different sections can occur successfully. Philodendrons are known to have been collected from the wild as early as 1644 by Georg Markgraf, but the first partly successful scientific attempt to collect and classify the genus was done by Charles Plumier. Plumier collected approximately 6 species from the island of Martinique, Hispaniola, and St. Thomas. Since then, many exploration attempts have been made to collect new species by others. These include those by N.J. Jacquin, who collected new species in the West Indies, Colombia, and Venezuela. At this time in history, the names of the philodendrons they were discovering were being published with the genus name Arum, since most aroids were considered to belong to the same genus. The genus Philodendron had not yet been created. Throughout the late 17th, 18th century, and early 19th centuries, many plants were removed from the genus Arum and placed into newly created genera in an attempt to improve the classification. Heinrich Wilhelm Schott addressed the problem of providing improved taxonomy and created the genus Philodendron and described it in 1829. The genus was first spelled as Philodendron, but in 1832, Schott published a system for classifying plants in the family Araceae, titled Melitomata Botanica, in which he provided a method of classifying philodendrons based on flowering characteristics. In 1856, Schott published a revision of his previous work titled Synopsis Eroderum, and then published his final work, Prodromus Systematus Oroderum, in 1860, in which he provided even more details about the classification of philodendron and described 135 species. Philodendron are usually extremely distinctive and not usually confused with other genera, although a few exceptions in the genera Anthurium and Homalamina resemble philodendron. The genus Philodendron has been subdivided into three subgenera: Mechanistigma, Pteramicium, and Philodendron. In 2018, it was proposed that Philodendron subgenera Mechanistigma be recognized as a separate genus, Thaumatophyllum. The genus Philodendron can also be subdivided into several sections and subsections: Section Borgia, Section Philopsamus, Section Philodendron, subsections Echeuropodium, Canophylium, Macrolunkium, Philodendron, Platopodium, Sauropodium, and Solanesterigma, section Calostigma, subsections Buloana, Eucardium, Glossophyllum, Macrobellium, and Oligocarpidium, section Tridomophilum, section Schizophyllum, section Polytomium, section Macroginium, and section Camptoginium. Typically, the inflorescence is of great importance in determining the species of a given philodendron, since it tends to be less variable than the leaves. The genus Philodendron could be classified further by means of differentiating them based on the pattern of thermogenesis observed, although this is not currently used. Philodendron diverged from Andalonema and diversified during the late Oligocene, circa 25 million years ago, in the New World. Philodendron species can be found in many diverse habitats in the tropical Americas and the West Indies. Most occur in humid tropical forests, but can also be found in swamps, on riverbanks, roadsides, and rock outcrops. They are also found throughout the diverse range of elevations from sea level to over 2,000 meters above sea level. Species of this genus are often found clambering over other plants, or climbing the trunks of trees with the aid of aerial roots. Philodendrons usually distinguish themselves in their environment by their large numbers compared to other plants, making them a highly noticeable component of the ecosystem in which they are found. They are found in great numbers in road clearings. Philodendrons can also be found in Australia, some Pacific islands, Africa, and Asia, although they are not indigenous and were introduced or accidentally escaped. Philodendrons can be grown outdoors in mild climates and shady spots. They thrive in moist soils with high organic matter. In milder climates, they can be grown in pots of soil, or in the case of Philodendron oxycardium, in containers of water. Indoor plants thrive at temperatures between 15 and 18 degrees Celsius and can survive at lower light levels than other houseplants. Although philodendrons can survive in dark places, they much prefer bright lights. Wiping the leaves off with water will remove any dust and insects. Plants in pots with good root systems will benefit from a weak fertilizer solution every other week. New plants can be grown by taking stem cuttings with at least 2 joints. Cuttings then can be rooted in pots of sand and peat moss mixtures. These pots are placed in greenhouses with bottom heat of 21 to 24 degrees Celsius. During the rooting, cuttings should be kept out of direct sunlight. Once rooted, the plants can be transplanted to larger pots or directly outside in milder climates. Stem cuttings, particularly from trailing varieties, can be rooted in water. In 4 to 5 weeks, the plant should develop roots and can be transferred to pods. Philodendrons can also propagate through air layering, which is a more advanced method of propagation that involves creating a new plant on the stem of an existing plant. Hybridizing philodendrons is quite easy if flowering plants are available, because they have very few barriers to prevent hybridization. However, some aspects of making crosses can make philodendron hybridization more difficult. Philodendrons often flower at different times, and the time when the spathe opens up varies from plant to plant. The pollen and the inflorescence both have short lives, which means a large collection of philodendrons is necessary if crossbreeding is to be done successfully. The pollen life can be extended to a few weeks by storing it in film canisters in a refrigerator. Artificial pollination is usually achieved by first mixing the pollen with water. A window is then cut into the spathe, and the water pollen mixture is rubbed on the fertile female flowers. The entire spathe is then covered in a plastic bag so the water pollen mixture does not dry out. The bag is removed a few days later. If the inflorescence has not been fertilized, it will fall off, usually within a few weeks. The resins produced during the flowering of monstera and philodendron are known to be used by trigona bees in the construction of their nests. Indigenous people from South America use the resin from the bees' nest to make their blowguns air and watertight. Though they contain calcium oxalate crystals, the berries of some species are eaten by the locals. Additionally, the aerial roots are also used for rope in this particular species. The leaves of philodendrons are also known to be eaten by Venezuelan red howler monkeys, making up 3.1% of all the leaves they eat. Also, in the making of a particular recipe for curare by the Amazonian Tawanos, the leaves and stems of an unknown philodendron species are used. The leaves and stems are mixed with the bark of Vachisia ferruginea and with some parts of a species in the genus Strychnus. Yet, another use of philodendrons is for catching fish. A tribe in the Colombian Amazon is known to use a part of the philodendron to add poison to the water, temporarily stunning the fish, which rise up to the surface where they can be easily scooped up. To add the poison to the water, the leaves are cut into pieces and tied together to form bundles, which are allowed to ferment for a few days. The bundles are crushed and added to the water into which the poison will dissipate. Although the toxicity of this part of the philodendron is not fully known, active ingredients in the poisoning of the fish possibly are coumarins formed during the fermentation process. Some philodendrons are also used for ceremonial purposes. Among the Cubio tribe, native to Colombia, Philodendron insigne is used by witch doctors to treat ill patients. They use the juice of the spathe to stain their hands red, since many such tribes view the color red as a sign of power. Philodendrons can contain as much as 0.7% of oxalates in the form of calcium oxalate crystals as raphides. The risk of death, if even possible, is extremely low if ingested by an average adult, although its consumption is generally considered unhealthy. In general, the calcium oxalate crystals have a very mild effect on humans, and large quantities have to be consumed for symptoms to even appear. Possible symptoms include increased salivation, a sensation of burning of the mouth, swelling of the tongue, stomatitis, dysphagia, an inability to speak, and edema. Cases of mild dermatitis due to contact with the leaves have also been reported, with symptoms including vesiculation and erythema. The chemical derivatives of alkanol resorcinol are believed to be responsible for the dermatitis in some people. Contact with philodendron oils or fluids with the eyes have also been known to result in conjunctivitis. Fatal poisonings are extremely rare. One case of an infant eating small quantities of a philodendron, resulting in hospitalization and death, has been reported. This one case study, however, was found to be inconsistent with the findings from a second study. In this study, 127 cases of children ingesting philodendrons were studied, and they found only one child showed symptoms. A 10-month-old had minor upper lip swelling when he chewed on a philodendron leaf. The study also found the symptoms could subside without treatment, and that previously reported cases of severe complications were exaggerated.